This is an example of a question from JEE exam. The relation from P to Q is, so they have given 4 options: a universal set of P cross Q, an equivalent set of P cross Q, a subset of P cross Q. To answer this question, we need to understand what is a relation, and we need to understand what is a set. Then we need to understand what is this P cross Q. So first of all, we'll start with relation. What is a relation? In real life situation, if you want to understand the relation, when you click a button on remote, your TV will respond. If you are switching on through remote, TV will be on. Here, the remote is a relation. Remote is a relation, and the relation is a link between you and the TV. The same here in mathematics, relation is a link between two sets. Relation is a link between two sets. Okay, here we should understand what is set. Set is a well-defined collection of objects. Well-defined collection of objects. For example, if you take A as a set, so we have to use a curly brace, open curly brace, and let us take this 1, 2, 3 as A set, and let us take the B set as 2, 4, 5. And this A can be symbols also, like $sign, @ hashtag, and B can be greater than, less than or equal to, greater than or equal to. It can be any objects, but it should be well defined. Set should be well defined. And another thing we should understand here is Cartesian product. What is Cartesian product? So Cartesian product will have set of all ordered pairs from set A and set B. So we have taken set A as 1, 2, 3. Let us take 1 and 2. Set A as 1 and 2 and set B as 2, 4, 5. So let us take the set A as 1 and 2. Set B as 2, 4, 5. So if I want to pair up these numbers, like I can take 1, 2. I can write 1, 2. And I can write 1, 4. So I can pair up this. Likewise, I can pair up 1, 5. And I can pair up 2, 2, 2, 4, 2, 5. So I'm going to write everything. And this set is nothing but the Cartesian product of A and B. So a set of all ordered pairs. Why we are calling that as ordered pairs? It means that A, let us take the small a as the first element and B as second element. So A should be, I can write this A cross B. A comma B is a pair. A should belong to set A. B should belong to set B. So if you take all the pairs, it has A first element, B second element, A first element, B second element, it goes on. That's why we are calling that as ordered pairs. So we have seen these three things. What is a relation? What is a set? What is a Cartesian product? So here we should know about universal set, equivalent set, subset. Before that, when I have a relation, for example, if I have a relation R and B is equal to 2A. So R is B is equal to 2A. I can write this relation A is related to B. So A is related to B. So we are using the same A. We are using these two sets A and B. So I am relating A with B. So I'm going to relate this is in a form A comma B. B is equal to 2A for A belongs to set A, B belongs to set B. And this is one of the representation, and we call this as set builder form. So I'm going to write in another form. If I want to pick the ordered pairs from the Cartesian product of set A and set B, I can write that as 1, 2 and 2, 4. So B is equal to 2A. If I substitute A as 1, I'll get B is 2. So the order pair is 1, 2. And if I substitute B A as 2, 2 times of 2 is 4. So A is 2. So the order pair is 2, 4. Only these two order pairs that satisfy the given relation. So I have two ordered pairs. And this form is nothing but the roster form. Roster is nothing but the list, and it's a list of ordered pairs, so it is called as roster form. So if I want to represent the relation in Venn diagram, so let us take A cross B as a set. Okay. And whatever the relation that is related to A cross B will be subset of A cross B set. So R is subset of A cross B. R is subset of A cross B. So how many subset you will get? So total number of subsets. Total number of relations you can form from A cross B is, so 2 to the power number of elements of A into number of elements of B. So here number of elements of A is 2, number of elements of B is 3. So you get 2 to the power 5. So 2 to the power 5 elements. So you will get 2 to the power 5 relations. You will get 32 relations. So you will get 32 subsets. Depend on the given relation, we can get two types. One is empty relation, another is universal relation. Okay, so we'll get the same Cartesian product. From this Cartesian product A cross B, so I'm going to write two relations. One is R is equal to A comma B. B is equal to 3A for A belongs to set A belongs to set B. So the roster form for this relation is null set. If you take any element from set A, if you multiply with 3, you will not get any number which is in B. So if you multiply with 1, you will not get 3. You don't have 3 in set B. If you multiply by 2, you don't have 6. 3 times 2 is 6. You don't have 6 in set B. So that's a null set. So if you have null set for a particular relation, we call that as empty relation. So definition is given in the book. You can refer the definition. And if I want to discuss about another type, I'm going to take another relation, B greater than or equal to A. B greater than or equal to A for A belongs to set A and A belongs to set B. If you take the order pairs B greater than or equal to 2A, so if we take 1, so 2 is greater than A, and if I take 1, 4, 1, 5, 2, 2, 2, 4, 2, 5. So 2 is greater than 1, 4 is greater than 1, 5 is greater than 1, 2 is equal to 2. So we have greater than or equal to. So that pair satisfy the relation. 2, 4, 4 is greater than 2, 5 is greater than 2. So if you observe, all my order pairs from A cross B got into this relation. So if a relation that connects A and B is equal to the Cartesian product of set A and set B, if they are equal, then we call this as universal relation. So universal relation is different from universal set. Universal set may have different elements of A cross B. So A cross B elements are taken from universal set. Okay, we'll come to this problem. A relation from P to Q is a universal set, or P cross Q, or equivalent set of P cross Q, a subset of P cross Q. So they are talking about this relation. So answer is a subset of P cross Q. So we have learned relation. What is relation? We have learned set. We have learned Cartesian product. And we have taken one example of relation. And we wrote set builder form and roster form for the same relation. And we learned that any relation, by using particular two sets, that would be subset of that particular sets. And the total number of relation is this formula, 2 times of n of A into n of B. And we have taken two different relation to understand empty relation and universal relation. That's all about relations in the chapter 1. So this is just part 1 of the introduction. Thank you.